Good evening, everybody. Today is Monday, March 14th for CAD 214 MEP. Today in class, we're going to be starting our electrical project. I finished grading all the midterm exams. Everybody did really well on those, and your grades are shown on Canvas. That's the same grade that you'll be getting when the grades come out, when they get published. So all that's done. So good job with it. If there was any corrections or anything that was off or I caught on there, I did make a note so you can see what was off on your drawing on your midterm. Going forward for the rest of the semester, this is pretty much a breakdown of what we're going to be doing till the end. For the next 2 weeks, we're going to be doing electrical plans. So we'll have varying projects and mods due, but we'll finalize all our electrical work on the 23rd. For plumbing, we'll dedicate 2 weeks to plumbing, and all that work will be due on the 6th. And then for your final, you're going to have a final project instead of a final exam. So I've allotted 3 weeks for the final project. That final project is going to be due on May 2nd. And we'll go into more how the final project's going to work when we get there. It'll basically just be a conglomeration of HVAC, electrical, and plumbing in one project, but we can go over that when we get there. Even though I'm giving you 3 weeks for that final project, you can turn it in early. So if you get your final project knocked out early, then you're done for the semester and that's it, because the final project will count as final project and your final exam. No separate final exam for y'all in this class. So that's how the rest of the semester is going to run. And so pretty straightforward. Obviously, electrical and plumbing, not a lot to go over in those two kind of things. They're really easy to learn, especially when we get to plumbing. It's just a matter of just kind of running everything. Probably the biggest hurdle that anybody has in electrical, just like they have in HVAC, is doing any kind of calculations. So today in class, we're just going to jump into calculations, how that works, kind of go through this, and then what you'll need to do is go back and complete your calculations before Wednesday, and on Wednesday we'll jump into how to apply that into Revit and how to create our Revit electrical plan. So let me jump back to Canvas for a second. So in our files, we have a new electrical folder. This is just a little example of how electric plan is going to run there. And all this stuff will be brought in through Revit, and we can just have that imported with the different, you can see the legend of what these different ones look like: ceiling lights, recessed lights, learn how to do all that, ceiling fans, and then our switches and stuff. We'll go into this a little bit more when we start the Revit part. This is just a good example for you to refer back to keep referring back to for this, just as you start laying out your Revit part of it. This is for a house. The same information applies for commercial. We're going to use the same commercial building that we did before, but you can refer back to this for this product plan, and then also for your final project. So that is available there. The information that we're going to be going over today is in your electrical file as well, and it's how to calculate lighting for optimal uses. So if you want to open that and read along, or I've got it open and I'll just kind of read along with you. For the mod we're going to be doing mod 5, electrical part 1. And for that, you're just going to upload your calculations. We are just going to be using the same Revit floor plan that we did before, the same one. And we did for HVAC, we're going to be using the same for electrical. And then I'm going to just kind of refer to different rooms for you. So when you have to do your lighting calculation, you'll know what they're used for. Like we have our stairwell, obviously, and then this is obviously our hall, but we're going to designate some bathrooms and some laboratories, some offices, some classrooms. And then we can change the lighting schemes a little bit in each one. Any questions so far? All right, next thing we're going to do is just kind of run through this, how to calculate lighting for optimal uses. I'm going to read through this because it's just the best way, and then I'll kind of explain it a little bit. What's nice about this, it's probably the easiest way to create our calculations for electrical, and it does apply for both commercial, industrial, and for residential. And I find it probably the easiest one. There's so many different ways to calculate stuff, but I find this is probably the one that from previous classes people have less frustration over for this one. So let me read through it, and then we'll go through an example of what you'll be doing, and then we'll talk about our project and how this is going to apply to it. So pretty straightforward. While designing your building, performing a lighting calculation can help you determine how much light you need for each room and for various tasks. This information will teach you how to calculate those lighting levels. You think about how you're going to work, what you're going to be doing in each room. Each room requires a different lighting and things like that, especially when we're working on a commercial building, depending on what goes on in each space. For your home example, you may have less lighting in your living room, or you want to have dim lighting, where if you're in your kitchen, you want to have a lot more lighting there. So you can be able to use it as a general space, and also for your food prep area and things like that. So there's definitely a lot of some things you want to think about when you're thinking about how to lay out your lighting plan. Okay, back to here. It may seem tricky at first, but luckily there are lighting tables available that list how much light is required for various rooms and tasks. In the end, you'll only have to multiply a few numbers together to find the light level you need for each room. That's a relief. You know, a couple of multiplications, and it's not calculus or anything involved in this, so it's not too bad. Just some general lighting terms to start. Lighting tables. The lighting tables you'll be referencing will tell you how much light you need for each room or task well, this was in either foot candles, which is imperial measurements, or lux metric. I've eliminated all the lux metric stuff in here besides for this one line, just because it confused people previously. But the main thing is that we're going to be calculating foot candles, which is an imperial measurement. So what does that mean by foot candles? It seems like such an archaic term, but it's still used in industry. It's just, you know, an odd way you think about it. It seems so primitive, but it's still used. Okay, so let's define a few lighting terms. Candela. This is one you've probably heard before. So one candela is equivalent to the illumination from one standard candle. And I just gave you a little, some information here if you want to find out more about it, but that's the most basic definition of it. One candela is equivalent to the illumination of one standard candle. And what kind of standard candle? Well, it would be 1 foot candle. For the imperial system, 1 foot candle is the amount of illumination on a surface created by a light source of 1 candela that is 1 foot from the surface. So it's like a 1 foot candle on that surface, and how much light is spreading from that 1 candle on that surface. Once again, sounds primitive, but still used today. So when you talk about foot candles of light, that's really what we're referring to. When you purchase light bulbs, I'm sure you've noticed this before, there will generally be 2 numbers of interest on the package. One is watts, which measures the power draw of the bulb, and the other is lumens. For those using feet, 1 foot candle is equal to 1 lumen, or 1 square foot. So I should highlight that as well. So in order to calculate your lighting needs for a given room, you check the illumination chart. We have that down here. For the optimal number of foot candles for a given task, and then multiply by the square footage of the room to obtain the required number of lumens. A lot of words, sometimes it's just easier to go through the example, and we're going to do that. So this is our chart. So for hallways, you know, and it does depend on the length of the hallway, 5 to 7 foot candles. That is a very large hallway in our building that we're going to be working on. So we probably want to actually maybe increase this as we develop that. We'll probably use like more of this general foot candle usage for entertaining. So we have more lights here. So if you have hallways, entertaining, dinner, easy reading, this would be like an office space. I would also say this is office space. Bathrooms, we're going to be doing bathrooms. We'll have kitchen, basic lighting, and food prep. Obviously, if you're doing food prep, you need more light. We'll be including a break room in our floor plan. So we'll be using this kitchen lighting as well. Difficult reading or writing, we'll use this for our offices. General workshop lighting and fine detail work. We'll use this fine detail work for the space that we're going to be calling our lab space. And we'll go ahead and break that down after we go through this, of which space is which. Okay, so this is the example. And I'll read through it and we'll talk through it. And it's really just best to kind of get in there and, you know, play with it and figure it out. It's hard to, you know, I can explain it to you here, but you really have to get in there and do it. So these calculations will be due by noon on Wednesday. That way I'll have time to grade them before class Wednesday evening. So lighting calculation example below is calculated using imperial system feet. So as the example, they're doing this for a 10 by 12 foot kitchen. For our basic general kitchen lighting, we know from the table that we'll need 20 to 50 foot candles. And then for food preparation, we'll want more like 50 to 100 foot. So these are where they're getting their two calculations from, 20 to 50, 50 to 100. So we'll start by calculating the area of the kitchen. We know how to do that, 10 by 12 feet equals 120 square feet. Now, to calculate the required lumens for the kitchen, we multiply the number of foot candles. So here we have 20 to 50 for basic lighting prep. And they're going to do like the minimum, the dimmest lighting would be 20 per square feet. And for 20 square foot candles, you'll do 20 times 120 square feet equals 2,400 lumens is the lowest, is the most dim lighting that you'll have. And then they'll do the same for the maximum amount. So the maximum amount of lumens would be 12,000. So 2,400 to 12,000 lumens for your kitchen is a wide range. What's nice about kitchen lighting is you want to think about how that would be applied. There's many different ways that you can apply your lighting. You can use recessed lighting, you can use some chandelier lighting, and then you can also use under cabinet lighting, and that would all, you can also use that for your prep area. So very large difference as far as our lighting is concerned. Then you can also think about what kind of windows are there. You can take the windows into consideration, and so lots to think about how you want to lay out that lighting. And we'll talk about layout next time as well. So how do we define that into how we've got our lumens calculation. How do we define that into actual lights per room? So everybody's kind of moving towards CFLs for compact fluorescent lights. The luminance tends to be about 40 to 70 lumens per watt for power draw. Incandescent lights are more like 10 to 17. And then for our example, we're going to use a 20-watt CFL rated at 1200 lumens. So for the lowest lumen requirement of 2400, if we divide 2400 by the 1200 lumens of that 20-watt bulb, you will only need 2 bulbs in that 10 by 12 foot square for the lowest setting of your light. For the highest setting of your light, you're going to be looking at 10 bulbs. So once again, we have our calculations. The minimum amount of lighting that we need for our kitchen is 2 bulbs. The maximum is 10. And we want to have a maximum so we don't blow out our lighting throughout a room as well. If we put like 15 bulbs in here at that amount, you know, that is going to be too bright for your room, and it's not going to be a comfortable room to sit in. So that's why we want to have that minimum and that maximum amount. So for here, what I would tend to do is I would tend to lean towards the higher amount. And this is where I would think about how I'm going to have the distribution of my my lighting. Let me go back to this. So you see, we have many different ways that we can insert different lighting into there. So for my kitchen specifically, and I have a kitchen example. Oh, they do have a kitchen example here. These are recessed lights that we could put here. And then I can also indicate if I wanted some under cabinet lighting here. And you can use a variety of lights to bring your lumens up to the spot that you want. And we'll talk about how we're going to access those in the next class. So we want the minimum and maximum amount of lumens. And that way that'll translate to how many bulbs we're going to use. And then on here, it says that seems like a lot of light, but if you consider all the possibilities for a kitchen, dimmable recessed lights, some under cabinet lights, the light on the stove vent, etc., you can easily reach 10 bulbs. So it's better to have more lights than none, because if you have more lights, you can also always go down on the wattage of your bulb as well. And then for more information, for some, however, this level of 12,000 lumens may simply be too bright for more personalized lighting design. Do a few calculations. This just gives you some more information of how you can compare the lights and how they work in your current space, and you can get a better idea of how that will translate to the real world. I'll let y'all read through that section. And then also just general information. Keep in mind that any kind of light shade over a light fixture, whether it's colored glass or anything, will lower the number of lumens and output for the bulb. And kind of like as a general like loophole for all this stuff, I like how they tacked on the end of it. Is some or all lights can be put on a dimmer switch. So basically they're just saying, no matter where you are in this, you can always put everything on a dimmer switch. And if you have the option to put everything on a dimmer switch or put things on dimmer switches, it does work out a lot better because you have the ability to control that light. Because sometimes, say for instance, in a living room, you may be using that as an office and you want more light in there. And sometimes if you're doing that for, if you're having a dinner party, you want to have a lower light setting just because you don't want to blast everybody out with light. So some hard and fast calculations there, but how we actually apply those calculations, we have some leeway as far as how we're actually going to put them into our space. So keep referring back to this in order to create those calculations. Let's jump next back to our floor plan that we're going to be using for this project. Same floor plan that we used before, same office building. So I'm going to go through here on these different spaces and just kind of give them different labels so you can use those to calculate your different lighting. And then I'll go back through, I'll resubmit this on Canvas of how the different lighting will be equivalent to here. Like we're not going to be doing any entertainment in this building. you know, the bathroom lighting's good for, we'll use this for our break room. We'll use this for offices, and we'll use this for our lab work and things like that. So I'll go back and redo this and resubmit that to you for the work rooms that we're going to be doing. But I do want you to take note of these specific rooms that we're going to be talking about right now. So starting in the upper left-hand corner, obviously this is stairs, so we'll just use that as circulation for your lighting. Hallway here. Let's list this as an office. This is going to be our lab. This will require a lot more lighting in here. This will be a classroom. And do women's room, men's room down here. And we'll do office and classroom. So once again, stairway, office, lab, classroom, women's room, men's room, office, class. And I will upload that correct information back to Canvas and put that in your mod for you, how to translate that so it's clear. You'll have a new lighting chart to go off of, because we're gonna, oh wait, I did want to incorporate one other thing. Oh, I almost forgot. Let's back up and change this room, actually this room in the center, make this the break room, and we'll use kitchen lighting for this break room. Stairway, office, lab, classroom, ladies, men's, classroom, break room, office. And I'll resubmit that to you so you have that information.
Wait, was that last room lower left, office or classroom? It doesn't, I'm sure we'll get it.
I think I keep going back and forth over which one is which. Yeah, let's say classroom and office. Classroom, break room, office. I'll have to go back and look at this recording just to make sure I have it right too. So,
Okay, cool.
yeah, stairs, circulation, hallway, office, lab, classroom, ladies, men's,
Classroom,
classroom,
break room.
break room, office, classroom.
Cool.
I keep getting that backwards. Okay, all right. So yeah, go ahead and work on your calculations, get those turned in by Wednesday, and then I can get those graded and back to you before class on Wednesday, and then we'll talk about how we're going to apply these calculations in an actual Revit drawing, which will be this one. Any questions, guys? All right, if anything comes up, if you do have a question about anything, feel free to shoot me a text, and we'll just see y'all on Wednesday.
Thank you.
All right, bye guys.